Today I'm going to start a new topic called two-port networks. Okay, what is a network? Network is nothing but it's an interconnection of element with or without a closed loop. So, for example, if you take the circuit, here is a circuit with the different elements. Okay, so if you look at it, we can call this as a circuit as well as network. Network is nothing but if you look at here, your starting point and ending point, both of them are different. I mean, you cannot come back to the same starting point without touching any element more than once. That's called network. Whereas circuit is nothing but interconnection of, so if you look at the circuit, it is interconnection of elements with at least one closed path. So start from here, come back to the same point without touching any element more than once. That's called circuit. Network is just interconnection of elements, need not to have a closed path. Now a port is nothing but two terminals of a circuit with the current entering one terminal and the same current leaving another terminal. So if you look at here, say for example, there are two terminals here. Whatever currents go out, say I have some other element here connected RL, same current is coming back. Okay, so these two terminals are called port. Port is nothing but two terminals, a current, whatever current is entering those two terminals, or whatever current is entering through one terminal, the same current must leave through the other terminal is called a port. Two-port network is nothing but it is an electrical network with two separate ports for one input and one another port, one for output, one for input. So if you look at this circuit, so here I have three elements connected, so we call this as a network here because there is no closed path. Okay, so but here if you look at this network, I have two ports. That's a port 1, that's port 2. This is port 1 and port 2. So this is called two-port network. So out of these, one port, we're going to use one port as an input port, one port as an output port. So basically what I can do here, I can connect some source here as an input, so current is going to go through it, and another one is I can connect this as a output port with some load resistance. Okay, so one is input port, another one is output port. We have more than two-port networks like 3-port, 4-port, 5-port, but two-port networks are more famous than any other port. So here I'm going to discuss two important points about two-port network. First thing is two-port networks are most probably used in, I saw in mostly in communications, but as well as control systems and power systems. I see them in electronic circuits too. A simple example is, say for example, you have a transistor. I believe most of you already taking 492, you're talking about NPN or PNP transistor. So this is the base, collector, emitter. This arrow is going to be always on the emitter side. So if you look at here, these are the input terminals and these are the output terminals. Okay, so this electronic device, it has input terminal as well as output terminal. It's a two-port network. So most of the time these two-port networks are used in communication, control system, power systems, and electronic circuits. The next one, to characterize two-port networks, to find out other parameters in the two-port networks, we have to relate input quantity. That quantity might be like a voltage or current or power, or input quantities or relate to the output quantities, out of which, so we have two input quantities and two output quantities, out of which two of them are always independent quantities. Two of them are always independent, two of them are going to be dependent. So we're going to have a relation between the input quantities to the output quantities. Thank you.